I went to a couple of movies this weekend. I went and saw Mercy on Friday, which is like a sci-fi thing. The whole movie, uh, the cop, he's a cop. He wakes up and he's strapped in this chair in this room, and it's the only thing in this room. It's a great big room, and he's just in the middle of this room in this chair. And there's one whole wall is an AI screen, and the AI is the judge, jury, executioner. So, and he's got 90 minutes to prove that he's innocent of killing his wife like last night. I mean, they got him immediately. In 90 minutes, she'll execute him. This chair has stuff that'll, zap him and kill him, right? So you got 90 minutes to prove that he's innocent. So that's the whole movie is him in this chair. So it's pretty intense, but it was done well. It was a good movie. So, and then we went and saw Shelter on Saturday, which is a Jason Statham movie. So it's all about him fighting against bad guys. That's every movie he makes. But I enjoy his movies. So he's trying to protect this little girl, and he's like an ex hitman who's kind of gotten out of the game and been hiding off the grid for years, and then they discover him, and it's that type of movie. So I don't know. I enjoy Jason Statham. It's just fighting the bad guys all the time. So, and yes, I got a new shirt, and I am that nerdy that I have a shirt that's an Excel spreadsheet. So I'm like, yep, I'm gonna wear that today. Let's get that going. I just got it in the mail, and so wearing it. And today's my wife's birthday, and it's Groundhog Day, so it's a busy week. Tomorrow is the bowling conference tournament, so I won't even be here all day. I'll be all day at the Fayetteville Bowling Alley. So yeah, it's a busy day. So yeah, my wife woke up this morning, saw her shadow, so that's 6 more weeks of homework. So that's too bad for her kids. So, well, all right. Well, let's see what we got today. I don't think today's got a whole lot of stuff. I don't think I did my work last week on here. Oh yeah, I did. Okay, let's put this up on the screen. See what we're doing this week. All right, let's go to the grade screen as usual. So we've done functions, we've done modularity. We were going to do data analysis last week, and then it turns out we didn't have it last week because pretty much the whole week got snowed out. So I moved it to this week, had to bump all of our due dates, just because when we just have a Friday, we're not going to do a whole week's worth of work on just a Friday. So data analysis is now this week's assignment. Notice we have a gap in there now, so well, hopefully we won't have any more gaps. We'll get pushed back so much we'll get behind on terribly. 4.03 data analysis. Next week is our first program of this semester, so we'll start with data analysis today. The numbers don't lie. Nearly every industry uses data analysis to help them discover information about their customers, come up with new ideas, and justify big decisions. Let's see how they define that. The process of inspecting, cleaning, transforming, and modeling data to discover useful information, suggest conclusions, and support decision making. Yeah, we've all heard of a data analysis. So here's just a few ways that some companies have used big data to do some things. So let's see what we got. Flip the cards to learn more. Google, by collecting and analyzing data on search items related to flu topics and user location. Google's able to help the CDC predict which areas of the country may experience a flu outbreak. Okay, that's a good use of our Google data because you never know what all they're tracking that you're doing. But if they see that a whole lot of people in one area are searching for ways to make the flu not so miserable, then they know, hey, there's a big breakout in this part of the country. Let's see. This would be Netflix. Yep. Every time you access its service, Netflix collects user data about the shows that you binge watch and those that you just quit watching and abandoned. This data is analyzed and used in decision making when predicting new series that are likely to go viral. So yeah, it's always got those suggestions for you based on the fact that you watched this show. Let me recommend these 18 other ones. That kind of thing. So it's using data analysis. And finally, Uber. Uber's notorious for using big data to its advantage when it comes to both drivers and passengers. So by analyzing its data in real time, Uber's algorithms can identify periods when lots of rides are requested. which automatically increases the price of the ride accordingly, known as surge pricing. Big demand, it's going to cost you more because there's only so many drivers available. And so they raise the prices based on the demand. So it all starts with just raw data, right? Spreadsheets. There we go. Before it can be analyzed and way before it becomes useful for decision making, collected information is simply known as raw data. It's data that's not been cleaned or processed to remove errors or find missing pieces, just loads and loads of stuff. Getting from raw data to data can be used, that data that can be used is a process that involves a few steps. So let's take a look. So data's journey, here's the journey. Specification. So before data is collected, there needs to be a question to be answered, such as where will the next flu outbreak be? Right? They need to make sure they got a lot of vaccines and stuff in that area, try to help people. Collection. Now it's time to collect the data, whether it's from user activity, databases, web pages, elsewhere, wherever the data comes from. Processing. After it's collected, the data needs to be organized before it can be analyzed, whether it's in a table, a spreadsheet, etc. Cleaning. So once organized, data is cleaned by removing duplicates, finding missing errors, missing data, identifying errors in it. Got to go through and make sure your data is good. Analysis. This is where the magic happens. So the data is interpreted based on the specification from the very beginning of the process. What data were we collecting? What did we need to know? Why were we collecting it? What are we figuring out from that? And then communication. You find something interesting in the data. So now what? You can share with others by putting it in an easily readable format, like a chart or a bar graph, an infographic. So data is huge in everything. And I love data. It's numbers usually a lot of times. Comparing data like a programmer. So where there's data, there's repetitive tasks. No doubt. And where there are repetitive tasks, there's a job for a programmer. So a well-written program can make quick work of data tasks that might take hours otherwise. Once the raw data has been cleaned up into a data file, a programmer's work begins. So data file to-do list. Check. First, make sure the data file is complete and consistent, right? Consistent being, in my mind, names are all saved in the same list, the same column or whatever, and that you don't have names spread out in different columns. Everything's consistent. When you look at this variable, it's all the same data in there. Open the data file. It's usually a TXT, which is just text, CSV, which is comma separated value, or XLSX is a spreadsheet, Excel spreadsheet. Review, skim the data, review some samples to understand the information that's in the file. That's good to know. Look for challenges. So check for missing values, outliers, determine how you want to handle those when you come across them. Look for patterns. Visualize the data with tools like Matplotlib. I've never used Matplotlib to create charts or graphs. So, anatomy of a data file. So, not all data is created equally. However, they all share some common elements and best practices for working with the information they contain. So, instructions. Select the following values in the data file to learn about each cell's value. Name, NA, transfer student, and the cell missing a value. So, let's see. So, we've got name right here. The first row of data is called the header and typically lists a category for the information. Somehow you got to have some organization that says what this data is. So this is the name. And so when you scroll down here, these should all be names. Now this has a name and extra information. So delete comments made in your file to avoid extra columns or unintentional text. So yeah, if we're pulling in a name and we're displaying someone's name, we don't want it to display transfer student with the name. So we would go and clean that up. It's like, okay, we want to get that out. Just the name in this column. We've got an age column right here, a GPA. So, hey, so there's some pretty sharp kids in here. Here's their major. So this is a list of college students, right? And the different majoring. Political science. Whew, feel sorry for this one. But no. Music, agriculture, all kinds of good stuff there. Gender right here. State. Now this one has an NA, so we got a problem there. Make sure that the missing values are indicated with an NA. So when they pull that up, they'll know we don't have all the data on this student, but you don't want it to be blank because that could be confusing as well. So they cleaned this up by putting not applicable, and it could be that this is a student that is a foreign student. They may be from another country. Maybe that's why they don't have a state listed in this list. And then housing. Do they have housing on campus, or do they have their own apartment, or whatever it is? So making sure you've got all the data. And then we got this one right here. We have just an empty line. Avoid blank spaces. They can cause an error in a program. So they need to put something in here, unknown or whatever, since this is the major that the student has. If they don't know the major or they don't have a major, they could put unknown or unavailable or something in there. Don't just leave a blank line generally, because it can cause some issues. Our programmer spotlight is on Katherine Johnson, a real life computer. Yeah, she's famous, very famous. Growing up in West Virginia, Katherine Johnson was fascinated by numbers. My type of gal right here. In 1953, this fascination earned her a job as a computer. They call them computers. She computed things. Okay, so she didn't get hired as a device. She got hired to compute things for the National Advisory Committee for Aeronautics, which later became known as NASA. Electronic computers weren't quite prevalent during that time. They had just a few of them around. So any mathematical computations need to be done by those with the job title computer, because her job was to compute numbers. Working for NASA, Johnson used her math skills to launch history, literally. She calculated the trajectory for Alan Shepard, the first American in space. She worked out the math for the Friendship 7 mission, when John Glenn became the first American to orbit the Earth. She even used her math skills to ensure the success of the Apollo moon landing program. So that's pretty impressive right there. Can you imagine calculating by hand trajectories of rockets, having to know that the Earth doesn't stay in the same place where it is when the rocket takes off when you want to land it? The Earth is constantly moving. The rocket's trajectory based on the thrust and gravity and all that kind of stuff. This woman has some mad skills in mathematics. So that's why she has become very famous over history, working with NASA. There's movies made about her. So, page 3. Now let's look at some data analysis tools. So copying data from one spreadsheet to another, reviewing thousands of rows of data, putting data in numerical, chronological, or alphabetical order. Boring. Well, yeah, for most people. I might actually get a little excitement out of it. Lucky for you, Python has tools so you can put all those annoying, repetitive tasks behind you. Skip straight to the fun part. So let's look at some of the tools we can use to manipulate and analyze data in Python. So there's a max function, finding large numbers. The max function returns the highest value found within a list. A function like this can be useful for analyzing data, like finding the highest temperature, the cost, the GPA, the height, age, whatever it is. So let's copy this. I know it has the output down there, but let's actually do a live version of this. Define main. Here's a list of numbers. And then we print the max. Notice we use max with parentheses, and we put in parentheses where your numbers are found, which in this case is in a list right here. So when I run that, it prints 4. We want to add another number that's larger. Let's put a 7 on the list. Oh, I put the parentheses. I put the comma in the wrong place. 7 comma. See, now it prints a 7. It'll just go through one and look at all your data and find the max value and print that for you. So that's pretty handy. Yeah, shows 4. Small numbers. If it has a max function, you can imagine it has a minimum function. So we can just go back to the same program and just change this to min. Now it's going to have -4, because that's the smallest number in this list of numbers we have up here. Adding numbers. Sum. So the sum function returns the sum of all the values in the list. So we want to find like the total price paid or total number of items or something. So let's change this to sum. 8. So -4 and 4 cancel each other out. We've got a 1 and a 7 and a 0. So 8 is the total of our list here. I'll make that look like the rest of it with our 7 added in there. So yeah, I can actually sum up a list of numbers rather easily for us without having to do this number plus this number plus this number. Yeah. So there we go. Sum of numbers. Did you know the many forms of data? When it comes to analyzing data, Python is a one-stop shop. The latest version contains a statistics module. All right, it can calculate the mean, the median, the mode, the standard deviation, the variance, all those things that true data analysts would like to look at. Despite this functionality, data is not the most pleasing thing to look at, even when it's cleaned up into a data file. That's why a plotting tool is handy to have in your back pocket. Use all the time in news stories and in jobs and with all kinds of data. Graphs and bar charts and all of that kind of stuff is a very useful way to be able to look at data and quickly kind of understand what it's telling you. So certain Python libraries like matplotlib, that's the one that been mentioned earlier, that is one of the things you can import in Python, provide tools to help programmers generate plots, bar charts, graphs, and more, making data both useful and beautiful. So interesting. I have to check into that a little bit. Okay, page 4. Before you can begin analyzing data, you got to open it in Python. We got to have the data to look at, right? Data can work with a variety of different file formats, including comma-separated values files. These are used to store data from spreadsheets or databases. So it's kind of like a generic Excel sheet. You can save an Excel sheet as a CSV, and it just, however many columns it has, it saves it with just a comma in between them. So column A and then a comma and B and comma and whatever data is in there, it just saves it with commas in between it, row by row by row. So any type of spreadsheet program, Excel or Google Sheets or whatever, can open one of these files and just import that and know which columns to put these things in. If there's an empty column when you save it as a CSV, it'll just put 2 commas in a row. You'll have the data from column A, 2 commas, saying, hey, skip column B, there's no information in that. And then we'll give the data from column C. So that's kind of how the CSV operates there. As the name suggests, data in this type is saved with commas separating the different values. So let's see, we got opening a CSV file in Python. Well, let's see, we have a built-in CSV file. Import this, open, interesting, with open, and here's the name of a file that I'm guessing must be saved into our Python curriculum here. Read CSV. So csv.reader. So there's something built in as a reader. The CSV file, because they're going to open this as a CSV file. And the delimiter says, how is the data separated? So the delimiter saying commas separate each column, all the data. So it knows, because it could be other types of data that has slashes in between there, or maybe even spaces in between there sometimes, periods. And for the row in the read CSV, print it and then close the file. So when we're done with it, we're going to close the file back. So let's run this. There it is. Look, it went and found somewhere there's a file saved that we can access called students.csv. And this went and pulled all the information. So we've got information on all of these students right here. It looks like the same thing we saw on the other page. Here's Michelle, name, age, 17, GPA is a 4.0, majors English, gender female, from Oklahoma, that has housing. So yeah, this is the same data we saw on the other page, but it just prints it here with this read CSV. So now we know what all data is in there. Look, it still has that. Oh, this has a little bit different information. It doesn't say transfer student. It's saying her maiden name, Amanda Berkeley, previously Smith, but it's got all this information on there. Interesting. So good to know. We've got some stuff to play with here. So, but we have to import the CSV. So that is a function, function with a bunch of commands that Python has access to. This is our command to open things with open. And then we have to give the name of the file, open it as a comma separated value file. And then here's this read comma separated value, which this is a variable name right here because we're setting it equal to something. So this is a variable. This isn't a Python code. It's something we created as a variable. And we're using the CSV reader to put information in this read CSV and print it. So take the file and separate things with commas. So we've got a Python guided activity to help us understand more about this. Okay, it looks like this may be the exact same thing we had up here. For row and the read CSV reader, delimiter, same file. So if we run it here, we'll probably get the same thing we just saw. I like how there's a hesitation a little bit because it's going out and it's pulling data from another source, another location. So it's going out on the internet, wherever this file is saved at, and it's pulling that in for us. But there is the information we just had on the other page. Python opens the comma separated value file named students.csv. It iterates through each row using a for loop right here, for row, print the row, and appends to a list called row. Actually, prints it. I don't see where it appends it, but all right, let's look at the next sample program here. Working with external CSV files, define main, import CSV. So this imports the CSV module. So they added some comments on it for this time. So with open students.csv, a CSV file, searches for the file and opens it. So that's where it goes out and gets that. This extracts the data from the file. Read, saves it under read CSV with that delimiter. Now we have 4-column print column. Oh, and this is just a column. So it's not a row. This is a column. So they're printing column 0, which was the name, if you remember. That was the first column we had. And I don't remember what column 4 is. Let's run it and see what it produces. Oh, first thing it does is the headings, because the very first row had name as the 0 item and gender. So this opens the file and just prints the name and gender of each student in the file. So we can just pull specific data out using this column command. So that's kind of handy. Creates a list, break the file into lines in our for loop using the in keyword in read CSV. Python understands that should break these files into lines. The final line, fclose, is used to close the file. I don't see the F closed. Was that in our database? We'll go back and look at our database. See if the last thing down there was it. Nope, the last one's a name down there. So I don't know where the F closed. They're talking about it. We had a close on the other. Yes, I know. I see it. Oh, here's the CSV close command. They didn't use that on the second one, so I don't know. Guess it didn't need it. It talks about the final line, f.close is used to close the file, but I don't see the final line there. Let's look at the next slide. Working with external files again, import this, same thing, with open as CSV file, extracts the data. There's the delimiter thing that there's commas used to separate all of our data. Save it again, prints name and state from the CSV. So run the program, review the module, modify the code. I would say when we run it, this is not going to do the name and state. This is gender. We're in the wrong column for state, right? Because this is what we printed last time. So let's see. I don't remember which one state is. Let's change it to 5 and see what 5 gets us. 5 is the state. So if we want to know the student and what state they're from, we just had to move it to column 5. So that's where it helps to run the first program to know everything that's in there, because we got to know what's in our data file. And then we can use that to just pick and choose which data we need. We just need to know what state all of our students are from. We can run it with column 0 and 5. So, all right, perfect. You were able to print the first and sixth columns of the CSV files, knowing that they count it from 0 to 5 as the first and the sixth file, column. So. Did you know printing on new lines and adding /n will create a new line? So let's check the examples below with or without. So if we just do this print statement, and let's load it into our Python here. We'll delete all that. We just add a print statement. This will print August 15th, welcome. But we can add in there that a /n right before the welcome, and it'll put new line. That's what this command means. /n means they go to a new line. So even though it's all in the same print statement, we can tell it on that print statement, hey, hit return, go to a new line, print this on the next line. And we could use that several times. We could say, wrong slash. Where's that slash at? Oh, there it is. It's above the enter. /n, glad you made it this. So we can see every time we use it, we can use it multiple times inside of a print statement, and it just adds another line. Just hits enter before it prints the next thing that comes after that. Don't have to put quotes around it. Don't have to put commas, spaces, or anything. I could take out that space and just, I added the space just a little easier to read, but it's going to produce the same thing because a space after welcome, we can't even tell it's there. So that's just something to help you clean up your output to make it look a little better, knowing you can use that /n for a new line. So, all right, that is it for this week. So let's look at the assignment that goes with it. How can a plotting tool help with data analysis? You've collected raw data on student GPAs. What's the next data analysis step? You're writing a program to average the students' test scores after discounting the highest and lowest. So we're going to throw at the top and bottom. Those are outliers. What's the average? What's the missing code required? So got to look at those and say, there's missing code right here. How do we find the average? But remember, we're going to throw out the highest and lowest before we take the average. Interesting. Let's see, which value for variable delimiter should be used? What should we put in there? If we've got this comma separated value, what's the delimiter? And here there's a file called text comma separated value, CSV, has this line in there, 1, x2, x3, x4, x5. What should the value of x be for the code to print 5? So where's the x? Where's the x? So if we had this in there, okay. You have to look at the value and see how this says that everything is saved. Look at what the delimiter is. That'll help you know what should be in between the data, because this is obviously different data. There's a 1, there's a 2, there's a 3, there's a 4, there's a 5. This is supposed to be what's separating each one. It's not commas. So looking at our code, we can see what it's looking for to separate all of the data in this file. And it's looking for a semicolon. So, all right, fellas. Next week, we're going to do a program where we get to pull information from this file outside of there and do something with it. So we're getting to the fun stuff and the stuff that really happens a lot out in the real programming world here. So, all right, guys, have a great morning. We'll see you later.